Welcome back. The map sensor adjuster LM317 circuit, you can not only lower the voltage below 5 volts, but you can also raise it above 5 volts. And when we discussed ignition timing, we found that there's a benefit to being able to raise the voltage above 5 volts. Here's a bit simpler circuit to build. And the map sensor, this portion here is not part of it. Of course, that's part of your vehicle. But just from here over, it's a 50K multi-turn pot. Something like this, only 50K. You're going to come off, there's 3 little legs. You're going to come off of one of the end legs with the resistor, anywhere from 33 to 60K ohms, and run that to ground. The center is going to go to your ECU. Remember, this is our signal wire that we're modifying here. With the LM317, we were modifying our VREF. This circuit, we're modifying the signal. So hypothetically, you could put both on and they wouldn't interfere with each other, except it'd be redundancy. But we take the signal from the map sensor and we're going to run it into this end of the pot. This switch is put in here just so that you can bypass it. Because of the way this is set up, if you turn this the whole way, because as you turn this knob, turn it the whole way one way, you'll have a short here and you'll have 50K ohms here. You turn it the whole way the other way, and now you have a short here and 50K ohms there. So by turning the knob the whole way, you wouldn't necessarily need the switch. So if you wanted to build one, eliminate the switch portion, you could. But the switch allows you to jump from here to here, eliminating all of this resistance. Since there's no voltage being fed in over here, there's nothing to short out. All you're doing is you're just jumpering from here to here with the switch, bypassing a resistive circuit. Much simpler to build, but the only way to go is down. The LM317 going into the VREF, we can go down, or up. Here, we can only go down. In other words, lean. In other words, timing advance. We're going to build both of these circuits. Any questions on this? All right. A lot of the things that we saw yesterday were things that were covered since the very first class back in June. Mistakes, wiring of the fuel cell, wiring of the optimizer. One vehicle that came in, the guy swore up one side, down the other. He checked and rechecked. He looked at that optimizer circuit 5 times. And it would be tripping some weird off-the-wall code. And he couldn't lean it out no matter what he did. Got in there, Mike got in there with his real fancy snap-on unit and discovered that instead of having tied in with the oxygen sensor circuit, he was tied in with the map sensor circuit. That's why you turn the key on, he had 1.47 volts. And then after 5 minutes, he was up there around 4.3 volts off the map signal. How's come that map voltage is changing with the timeout circuit? And why can I not adjust my oxygen sensor? Your kit is screwed up. The basics. It boggled my mind how many cars were delivered for tuning for the last class that the basics were just screwed up as all get out.
Mike, when I did all mine, I took the signal wire from the sensor and I put my own meter in that, and then I went to the computer and with the same wire.
Check for continuity.
Yeah, just to make sure. That's how I was certain I was on the right wires for everything. Doesn't take very long, and you got the schematic there to tell you which one to hit, and if you hit it and it's the right one.
Yep, Klaus.
Lincoln Continental front and rear 2 sensor wiring collars were reversed in the harness.
So you were adjusting the downstream.
Well, we
Yeah.
noticed this doesn't add up, so we actually
Mm-hmm.
physically verified wires from one end to the other, and that's how we found out that the schematic is wrong.
We
But
ran
that's a
into-
basic thing too.
We ran into issues where not one, we had 12 cars delivered last class. Out of 12 cars, not one was ready to pull up on the dyno and start tuning on. Yet that was the requirement that we insisted upon. Do the appropriate install. So all we have to do is tune it in the class. If that were adhered to, I told Allison we can crank out 30 cars. We can tune 30 cars in this class. We had all we could do to get through 12, and we wound up rejecting 3 of them. We're not even touching them. One was a Lincoln Town Car. I felt so bad for this guy. He came in, and at first I'm thinking, this guy's a butthead. Because he's over there, he's demanding, he's insisting, he's showing paperwork. I wasn't in on that conversation, but from a distance, I heard this going on thinking, oh, grief. And then I found out what he was saying. His best friend went through the class. His best friend did this install. The vaporizer was mounted, but the fuel lines were not connected. That kind of stuff. His best friend charged him $1,200. Excuse me, ex-best friend. No wonder this guy was so infuriated. If this is all the better you're training these guys, I think you got serious problems with your program. If that's all the better we were training you guys, we would. Needless to say, Allison revoked that guy's install license on the spot.
Oh yeah.
If that's all the better he's going to do, not only will he not be a trainer, he's not even licensed to install. We're not sending anybody to this butthead. Go back and check the bait. Yeah, Jerry.
Point, and I run into it more than once. The schematics are not always.
The schematics are not always correct.
Especially on that.
Absolutely.
You run into that. A lot of times you chase your tail.
Verify. If it's saying coming out of the ECU where you're working with your optimizer and pin number D18 is supposed to be a green wire with a red tracer, and that's not what's coming out, go to your sensor and actually physically eyeball it. Almost never do car companies change wire colors between the ECU and the sensor. Occasionally they do, but almost never. So if you have a green wire with the red tracer at pin D18 and a green wire with the red tracer coming up out of the sensor, but the computer says it's supposed to be a brown with the pink, go with D18, not brown with the pink. But if you go to D18, it says green wire with the red tracer, and that's supposed to be your sensor, and you go to the sensor and it's a brown with the pink, I'd question the whole thing. Sometimes you're just going to have to run one wire to the sensor. It's a lot easier than trying to go through each and every pin of the stinking harness, trying to figure out which one of those ECU wires wound up being that.
One question.
Yes, sir.
After you have it all hooked up and you put the scanner on and you get your readings, voltage, O2 sensor readings, and you get your coolant temperature reading, your temperature sensor reading, you should have it right, shouldn't you?
Well, you'll know.
Yeah.
You should have it right. You call it right.
If you have a fully warmed up engine,
Need to air out here.
key off, restart, fully warmed up. You should see your temperatures going up as the optimizer times out on both coolant and air temp. As far as the cold start, I'm going to move to that next. I wasn't ignoring you because I don't like you. I was putting you off because I'm going to cover that now, and I didn't want to go into it at that time. The 3X optimizers. I believe it's these two chips right here on the 3X optimizer. The bottom one is your coolant temp circuit. The top one is the air temp circuit. Those are called digital potentiometers. The 3X uses 10K ohm digital pots. At 10K ohms on a cold start, we're going between the signal wire and ground. Essentially, we're putting a 10K ohm resistor across the coolant temp sensor. And in cold weather, you turn the key on, and immediately it might be 20 degrees Fahrenheit out, but immediately your scan gauge is showing you 95-degree engine temperature. Cold start issue. Yes, Marie?
Just this little part.
More explain.
Yes, the difference of temperature.
Oh, like 20 degrees Fahrenheit would be probably about 8 degrees below 0 Celsius. And 85 or 90 degrees Fahrenheit would be like 32, 33 degrees Celsius. The engine's cold. It needs additional fuel to get started. But if the computer's seeing a half warmed up engine, it's not putting out near the amount of fuel needed to get the engine started. Cold start issues right off the bat. So we have 2 fixes for now, and then a permanent fix when we get the 4X program done. We're not dealing with it with a permanent fix now because we don't have the human resources. Our electronics guy is too tied up with the 4X, and frankly, that's more important to us than fixing the 3X cold start issues. For your temp circuits, we're splicing into the signal wire going back to the ECU. One fix, cut the wire. It's the easiest one. Cut the optimizer wire. Now we're not going to be telling the computer that the engine's warmed up when it's stone cold. Flip side is that we're not going to be getting the lean limit protection that we were getting with it in play. So if you lose your lean limits, well, you could go back with the map sensor and again do something like that. Or you could come in here with a switch. Now the customer is going to be responsible to flip it off, fire it up, a couple minutes later, turn it on. Hope they remember. Wish we could do better than that, but that's about as good as it gets for the moment. The permanent fix will be the 3X optimizers will be sent back. These 2 pins will be desoldered from the board, and in their place will go a 50 K ohm digital pot. Now, is this something that you can do at home? No. The reason is, with the 10 K ohm pot, or any digital pot for that matter, you have 256 steps. Each step has an address. The microprocessor here is programmed to tell these digital pots how many steps to take before they stop. A 10K pot, 10,000 divided by 256 is about 39 ohms per step. When you first fire up the optimizer, it starts out at 10K ohms, and then it'll drop down 39 ohms, 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 until it gets to the address that the microprocessor tells it to stop at, which is just something like 600 ohms. If we had a 50K pot, took the same number of steps, because the programming in here doesn't change unless we change it. Just by changing the pots, we don't change the programming. The microprocessor, no matter what pot is in here, is only telling how many steps to take. And at 50K going in, that's 195 ohms per step. So we might wind up with close to 4K ohms here when it stops. Can you see why we cannot just desolder and resolder? Once we change out the 10K to a 50K pot, we've got to go back and reprogram the microprocessor to keep on going a few more steps until it gets to approximately the same value as it had with the 10K ohm pot. That's the permanent fix. We've already got it figured out. We've already bench tested it. But we don't have the resources to implement it just yet. So your fixes are cut the coolant temp circuit wire, preferably put a switch in, or you can get thermal switches. A thermal switch is open, cold, and then closes when it reaches its rated temperature value. So if you get a thermal switch, how in the heck do you draw a thermal switch? I know it's something like this. Yeah, whatever. If you get a thermal switch, you want something rated at like 65 degrees Fahrenheit. 65 degrees Fahrenheit, hang on, don't tell me, let me work the math, I need to practice anyways. 65, 5 by 1.8. Would that be about 18 to 20 degrees Celsius, Marie? 65 degrees Fahrenheit, would that be about 18 to 20 degrees Celsius?
Well, 68 degrees is 20 degrees.
Okay, so something like, you know,
That's room temperature.
20 degrees Celsius. You can get a thermal switch. Put that in here. Take the thermal switch and epoxy it to a freeze plug. Strap it to a heater hose. Whenever the engine temperature gets up above that mark, then it will reconnect the coolant circuit into the optimizer. Yes, sir?
Where can you find one of the thermal switches? Radio Shack or something?
The only place, I know our electronics engineer sent me a data sheet on it. It was an NE something or another manufacturer, the ones that he sent me. No, Radio Shack's not going to have one. It's going to be online.
All electronics, maybe?
Allelectronics.com, you might be able to find it. Allelectronics.com will have your LM317s, your resistors, your potentiometers, all of the common stuff they always have. They're mostly like a clearinghouse. They have stuff in there, they get a lot, and when it's gone, it's gone. My wife had me buy one of those things. It's a cassette here, you pop it in, and then you can have your DVD player over here. They quit making those years ago. All Electronics bought out the last of them, and when they were gone, they were gone. My wife wanted one. Pardon?
Going back to your circuits down there, we're up in the northern part of the country.
Mm-hmm.
And we really run into problems there with cold starts.
Mm-hmm.
And the best thing to do that we found, at least that I found in mine, is get your intake air temperature right down. We have intake air temperature between 38 and 42 degrees on the scanner. Mm-hmm. Your vehicle doesn't start too bad. When it drops down to 35 below, with wind chill factors getting you at 40 below, mm-hmm. you're going to need more than that. So the best thing is to use your resistors and put a switch in it. Switch it off, tell your customer to switch it off.
Switches.
That's what we're working on.
The switches, I showed just a single pole, single throw switch there. You can get double poles. Now this one, you can go from center to out, but you'll see that there's 2 rows of them. So it's like having 2 switches in the same housing. You flip this once, you've affected both sides. You could put your air temp on the one, your coolant temp on the other, and you've affected both with the single throw of the switch. That's not the perfect switch because that one will either connect this way or connect that way. The 3-prong switch that I was showing earlier, that one is like 2 3-prong switches together. But they make them that have a total of 4 prongs. The 4 prongs is like 2 2-prong switches together, where it's either connected or it's open, but you're affecting 2 circuits at the same time, connected or open.
That's a double pole, single throw.
Double pole, single throw.
Right. I got one on that figure.
Okay. Any other questions on cold starts?
So what's the purpose of that? You haven't explained that.
The purpose of this is to take that which is preventing the car from starting out of commission. The optimizer is telling the computer that the engine's hotter than it really is. But you need that fuel for a cold start. So you eliminate the optimizer's ability to do that. That'll restore your cold start problem issue.
Then your computer will see real
Actual real time. But in this type of a climate, only affecting the coolant circuit will get you where you need to be. They're telling me that when it gets really cold, that you need both coolant and air temp circuits out of the picture in order to get the vehicle to start. Your air temperature is going to vary because it's in play. When you first start the car, do you have hot fuel coming out of the fuel vaporizer? But once the engine's been running, now do we have warmed up fuel? Okay. So we have that benefit. That means that we need less fuel total, regardless if it's 20 below outside or 120 outside. The fuel cell, when you first fire it up, if you've been through the class, you know that when you tune the fuel cell electrolyte concentration, the amp meter will start out at maybe 7 or 8 amps, and then it'll go up to 15 amps. So when you first start it up, you're looking at about half output from the fuel cell, and then it increases as it gets up to operating temperature. The air temp sensor is going to vary the readings back to the ECU as the air temperature itself actually changes. The problem is not the calibration, cold weather versus hot weather at operating temperature. The sensors are doing their job. We're not just putting a fixed value signal back to the ECU. As that air temperature changes, the reading changes. We're just offsetting it higher. The problem is getting the stupid engine started. You don't get warm-up conditions if you can't get it to start. So what I'm addressing here is how do you get it to start without coughing, choking, stalling? You go to pull out into traffic out here and you have a stall, it could be catastrophic.
We start off at 2 amps when it's so extremely cold. Check mine so often, you know.
The fuel cell that normally puts out 15 amps warmed up is putting out 2 amps at a cold start up in your neck of the woods. Okay. Are there any other questions on the cold start then?
That
Art.
issue won't be as,
Art.
Yes, my question is, all right, you're already ramping down. Even though you got that switch turned off. Now that switch turns on, now it's gonna go immediately from where you were to that hotter. Is that gonna be an issue by any chance?
I thought it would be. The whole purpose of ramping was to prevent any codes from being set. And we've been doing this switch technique pretty widespread in a variety of climates, and I am not aware of one single vehicle tripping a code because of it. It is surprising me. I was sure doing this would trip codes, but we've not had one vehicle actually trip codes that's been brought to my attention.
Well, I just wondered if maybe the ramping wouldn't start until that triggered on the 4X.
No, the 4X is timing out. Whether we're connecting to that circuit or not doesn't have any effect on the optimizer itself timing out.
You can run your engine.
Now, you had a question, Merle?
well, the difference between the 3X to 4X, the 10K versus, isn't it 100K, and that would eliminate
Well, the
that cold
4X is
start?
actually going to be 50K.
50 now?
It's going to be 50K. We were going to put a timed circuit on it. The Oktoberfest videos say that if it's, this temperature, we delay it 1 minute. If it's that temperature, 3 minutes, 5 minutes. And the electronics guy came to me with an idea, and he said, well, this here thermal switch thing that you wanted to do, can't we just put that on and we don't even start the timeout until the engine reaches a certain temperature? Yeah. Is it okay if I do that? Yeah. Okay, that'll make it a lot easier. So the 4X is going to have a thermal switch that you can either strap to a heater hose, epoxy to a freeze plug, but make sure that it sees pretty intimate engine coolant temperature. And then as the engine warms up, the optimizer sits there dormant. So if you live in Alaska and that never, ever, ever warms up enough to where the optimizer should be brought online, it'll never be brought online. If you're in the summer heat of Arizona, as soon as you turn the key on, that switch automatically closes. Even on a stone cold engine, stone being relative to ambient air, middle of summer, it just starts the timeout immediately. All right, now I heard a bunch of other questions. I was trying to remember who was in which order. Yes, sir.
In your drawing, that's the coolant temperature sensor in the bottom left corner?
Coolant or air temp.
Okay.
Coolant primarily, if you're in really cold, then just duplicate that portion of the drawing, call one coolant and call one air. Next question.
If you have a temperature gauge, you can follow your temperature gauge, but if you don't, as soon as you start feeling warm air coming through your heater, you can switch that switch and away you go.
That would work. play around with it. Maybe you can just let it run for 30 seconds and flip it. Maybe you have to let it run for 2 minutes and flip it. Maybe you have to wait until, you know, on a real cold day it's longer than on a warmer day. I feel so guilty forcing you guys into a switch position like this. That is something that violates the very parameters set forth for this whole optimizer program. But we got to do what we got to do. I also feel cheated having to give away some of my secrets so that we can get this going, but we got to do what we got to do. I'm assuming that at least half of you, maybe more, have done an install on your own, have done tuning on your own. Have any of you run into a situation where you've tuned it to, it drives beautiful out on the road. You got plenty of power, but when you come to a stoplight, the thing wants to stall. Even fully warmed up, it wants to stall. It just sits there, chugs and pops and coughs. But as soon as you get above that point, oh man, she comes alive and all is well. Wouldn't it be nice if you could fix that problem?
Any problem we can fix.
Well, any of you find a solution, let me know.
That's a secret in your next book.
Yeah, tune into our next hotline. Here's what you do. Write down a TPS number. Get on your scan gauge, write down your TPS number. Remove the limiter cap. Crack open the throttle until you get that smooth idle back. Now look at your TPS. Loosen the screws. Twist the TPS back to restore your original numbers and tighten it back down. If you have a TPS that is not adjustable, you have two options. One, make it adjustable. And if there's just no way come heck or high water because it's square or something, you can't twist a square in a square hole, then here's what you do. Remove the throttle body. Start out with maybe a 3/32 drill bit. Put a hole in the throttle plate. Put it back on. Go with a little bit bigger until you get it right.
Put a hole in the throttle plate?
Drill a hole in the throttle plate. A manual air bypass. Preferably, open the throttle itself and turn your TPS back. Now you may find that you look up the specs for the vehicle you're working on. TPS range might be like 0.4 to 0.8 volts. Anything in there, the computer's going to be happy. You go below this and you're going to cause problems. You go above this, you're going to cause problems. And let's say you go in there, you're 0.57 on your TPS volts. You can go in there and you can crack that up to 0.78. That might restore your idle and you're still within your range.
How big did you say the hole was? Start off with what?
336.
3/32, 1/16, something small. 2 millimeter. Just start out with something small. And then work bigger. If you have a large V8 engine, you might want to go to something like an 1/8 inch right off the bat, depending on how bad it is. If it's not too bad, you don't need a lot of air to restore it. If it's sitting there shaking and coughing because it's trying to idle at 200 RPMs, you'll have to probably go bigger. By the way, this is on being recorded. Mike Romero came up with this. I'm not claiming credit for this one. I like to give credit where credit is due. Mike Romero discovered how to solve this issue. I want to make sure everybody knows he's the man. Now, you've restored your idle. You've restored, it doesn't stall at stop signs anymore. And that tuning that you were able to get such good mileage out of, you can keep that tuning now. I'm teaching Mike's segment. He got his chance up here last class, and this is stuff that he was teaching. This is his way of doing things. I want it known that this is his stuff because I like to reward people with credit when they come up with innovative stuff.
Some vehicles have an electronically operated variable airflow valve in the throttle body, not the main.
Idle air control, yep.
Right.
But it has parameters just like everything else on the engine. And once it opens up, it'll open up this far if you got an AC command with the heavy load on the alternator, with the wipers and lights and everything going. But if you don't have all those other inputs, it's limited to here. It will not go above here. So even though it has that idle air control motor, it has parameters also, and it will not go above those. It'll stall before it'll increase that opening unless it has the right inputs.
Okay, so I guess what I'm hearing from you, because you're not saying it, you don't have a fix to modify that circuit. To put in, just as we're adjusting map and.
Yeah, I just gave you the fix.
No, he's
No,
saying
in a
to
4X.
to modify the idle air control, that would probably be too complicated, because I think.
Entirely, there's way too many different styles out there. If all you have to do is turn a screw and rotate a TPS, why do we got to create some complicated, elaborate microprocessor controlled something or another and make 15 different versions of it for all the different style idle air control motors out there? Because those are logic controlled. A TPS itself is just a potentiometer, a map sensor, potentiometer, coolant sensor, a thermistor. Idle air control motor is a stepper motor that has inputs and outputs going both ways. The computer's asking, how many steps did we take? And it'll command, we'll go another one. How many steps did we take? Okay, go another one. It's a lot more complicated than just messing around with pots and thermistors.
Did you do any more thinking about, like on the VWs and the Audis, throttle by wire, throttle actuator,
Drill the hole.
having two in there?
Drill the hole.
Okay.
So if you have a drive-by-wire and you got that drivability issue, it runs beautiful out on the road but stalls out on you, pull it off, drill the hole. You need to remove the throttle body and you need to drill it out, properly clean and deburr, then reinstall. All right, what was I going to go on to now? Oh, yeah, all right. That's your O2. Optimizer. No, they don't line up. What Mike Romero does is he has a scope. It's a snap-on automotive style scope that he can back probe. And what he does is he looks at the output of the optimizer. What he's looking for is this is a rich signal. A rich signal is a lean command. If our engine's rich, that's commanding to lean out. This is a lean signal, but it is a rich command. When the oxygen sensor says we're lean, it's commanding the ECU to go rich. So what Mike likes to do is he can sit in here, have somebody with their foot on the brake and one on the gas, just getting up there to torque converter lockup speed. He's got a mild load on it, or better yet, on the dyno. But he can tune the optimizer this close to where it's going to wind up being with the best of the best tune, just by looking at this signal output and how smooth the engine is. What he wants is a lot of lean commands. He wants that optimizer output signal staying on rich a lot more than it is on lean. Because when it's rich, it's saying, lean it out, man, lean it out. But we still need switching. It's got to go high, low, high, low. So he leans it out, leans it out, leans it out, watching his scope to try to get top-heavy square waves. He tuned a couple of them that way yesterday. Only one of them had to be richened up after the fact. Tell you what, I'm going to turn the time over to Grant, take about a 5-minute break.